Hi, everyone. We're going to get started. My name is Leo Zhadnovsky. I'm a Principal Solutions Architect here at AWS. And thank you all for coming. I'm going to talk to you today about AWS or Amazon CloudWatch logs and AWS Lambda and how they work together to help you get increased visibility into what's going on with your infrastructure and your applications, and how to also take action upon things that you get alerts on. And so if you're wondering why we have a logging talk in the DevOps track, it's because part of DevOps is visibility for your whole team. So having logging everywhere, making sure that you have proper alerts set on that logging, and making sure that you have proper actions on your logs. So as you automate more and more of your apps and your infrastructure, it becomes less and less feasible to manually log into servers, to go search for logs manually. And so you have to have centralized logging, and you have to have a good alerting set up for that. So I'll talk to you about how to do that. So just for what you should expect from this session, we're going to talk about some industry trends that we see that impact monitoring and logging. We're going to talk about Amazon CloudWatch and Amazon CloudWatch logs, and what the difference between the two of them are, how they work together. We're going to talk about some general monitoring use cases that we see, and we're going to show you how CloudWatch and Lambda work together to help you do a bunch of useful things. And so I'm going to talk about 3 scenarios in this talk. The first one is how to centralize logging. So with CloudWatch logs, right, you can install an agent on any instance to get those logs. But how do you actually centralize logs that you get in S3? So things like ELB logs in this example, or another example would be access logs from CloudFront from our CDN. So how do you centralize those logs? How do you import them into CloudWatch logs? We're also going to talk about how to customize alarms. And so how do you get alarms from CloudWatch? And how do you make it so those alarms are useful, and so that they actually, when you get the alarm, they display data that you can act on, not just, hey, there's an alarm that's been triggered. And lastly, we're going to talk about how do you analyze your log data. So how do you take a bunch of log data, how do you spin up an Elasticsearch cluster, and then do your analysis, and then shut it down, so you don't have a long-running cluster that you need to pay for. So first of all, let's talk about a common scenario that I see. I come from a DevOps kind of sysadmin background. So a common scenario I've seen both in my previous career and with a bunch of just people in the industry. So I'm sure a lot of you who work in operations or DevOps are familiar with the this is fine dog feeling, like this is fine dog. And so let's talk through a scenario here that I've seen happen way too many times. So this scenario is, it's true, I've seen it. So you've got an important app, and then your application, it's down. Now the first red flag here is you don't know it's down because you got it from your monitoring. You know it's down because a customer has filed a ticket that your app is down. So that's the first bad thing here. And so you've got the on-call developer, John. John gets paged through the ticketing system. And again, he only knows, not because some alarm fired, but because of this ticket. So this is the blissful ignorance stage of this incident. So you don't know anything has happened, except your customers are unhappy. So then John starts looking at service dashboards. John does see that there's some intermittent availability issues, but he doesn't know where to look to assess impact to customers, to begin troubleshooting. So that's another red flag, right? You don't know where to look. You don't have good dashboards. You don't have good monitoring. So John decides to escalate this to the manager. So this is the confusion and panic stage of the incident. And so then you get more customer tickets are pouring in. More customers are unhappy. The escalation manager, Jane, joins the event and starts to look at what's going on. So then, even worse, the CTO notices what's happening, and sends an IM, hey, what's going on, Jane? What's wrong with important app? This app. So this is where it starts getting stressful. And so because they don't have really good logging, they just start guessing at, based on previous experience, what the issue is. So Jane and John recall a recent issue where there are certain expensive operations done by customers that impacted the app. So they start diving into logs to confirm if this is what's going on. Again, because they don't have centralized logging, they have to go and log into specific production hosts and grep through the logs, and it's taking a while. And so John then identifies a suspect customer. John thinks he has something. Jane cuts a ticket and prepares to block that customer's expensive operations. But they don't have any concrete data that this is what's actually causing the issue. So this is the false hope stage of the incident. And so the other team gets involved. They indicate that there's nothing that's been changed. They indicate that this expensive operation isn't actually going on. And so even though they changed the configuration to block the customer, the issue is still happening. And so when they've run out of ideas, you always want to try, have you tried rebooting it? So they decide to fail over the database, right? And so this is the desperation stage. And they get lucky and it works. Rebooting fixes the issue. The app recovers, or actually not rebooting, but failing over to the standby. And so then they do the root cause analysis, and it turns out that the issue is actually there's a new JDBC version introduced. It had a memory leak. This led to Java heap exhaustion, and so that's why failing over to the standby fixed everything. So they fixed the leak. They add alarms on memory usage to prevent this from happening again, and they tune their service alarms. So this is the enlightenment stage. They figure out what's wrong, but this is all really reactive. You don't really want to, have disasters happen and then fix things. I mean, sometimes that happens, but you really want to get ahead of the problem usually. So we can definitely do better than this. So just some of the red flags here. We have poor monitoring. We didn't have any alarms here. Some of the alarms weren't actionable, so they found out, hey, maybe this previous issue, with expensive operations caused the problem, but they didn't know for sure. They didn't have access to the right logs right away. They had to access their production hosts. In fact, they were logging into their production host as potentially a problem too. And they didn't have dashboards, right? So again, they depended on customers to let them know they're down. So the bottom line is monitoring can be really hard, right? You have a lot of data, and as apps grow into microservices and get broken down, you just get more and more log data, and you got to do something useful with it. So let's talk about some trends we see in monitoring. So as I mentioned just now, we see a transformation in the industry from monolithic apps to microservices. So apps are being broken down into smaller and smaller pieces. Each of those smaller pieces ideally operate independently as much as they can. They each have their own logging. We see applications shifting more and more into a polyglot kind of setup. So you see different languages across microservices, different frameworks. We see workloads that are transient, right? So you can't assume that your app servers or wherever your compute is happening is going to stick around. So whether you're using auto-scaling groups or containers or serverless compute like Lambda, a container or a Lambda function might execute, it might disappear, an instance might disappear, you might scale up, you might scale down. So you can't assume that any logs you have stored on your compute layer are going to stick around. So you have to have centralized logging. And we also see specialization in the persistence tier. So we see customers using S3. We see customers using EBS for various things. We see customers storing things in DynamoDB, in Elasticache, whether through Redis or Memcached. And so you have to have logging data and all that as well. And we see applications becoming more dynamic. So as more and more organizations adopt DevOps, we see more and more people do continuous integration, continuous delivery, continuous deployment. So changes are becoming much smaller. Deploys are becoming much more frequent. As an example, in 2011, Amazon, internally, we did 50 million deploys across the company. I'm sure this year it's far, far more than that. And so you have to have logging on all your CI/CD, all your builds, all your tests, all your deploys. And we see that infrastructure needs to scale as well. So we see our customers going global. So I have customers who have their application where, it used to be just in the US, so they had to worry about US business hours. Now, there's no such thing as an off time for their application. So they have deployments in Asia and South America and Europe and the Middle East and Africa. And so your application is always on. It's always in use. You can always get a random spike of traffic that you can't predict. And so your logging infrastructure has to be able to give you a lot of insight for that. And lastly, we see an increasing role of automation. As applications get bigger in scale, you can't just manually log into the console or script things. You have to have automation. You have to have not just in your deploys and in your code, but you have to have automation in your infrastructure. You have to treat your infrastructure as code. And another trend that we see is that applications are having much more of an impact in business outcomes. So even as non-tech organizations get more they develop mobile apps, they have more use of technology, this technology impacts their revenue. And SLAs matter. And customers, their expectations are evolving. So I remember a few years ago, there's actually when I went to college, we had an application that it would only work during business hours. If you tried to change your class schedule at like 2 a.m., it wouldn't work. Customers don't accept that kind of thing anymore, right? Your application has to always be available and has to be rapidly evolving for you to gain competitive advantage over your competitors. And so another trend that we see is that logging and monitoring, it's not a standalone thing anymore. It's part of the application lifecycle. So you've got your provisioning your infrastructure, your configuration management, monitoring and performance, right, which we're talking about here, governance and compliance, resource optimization. Monitoring is part of all of these things, right? And logging is part of all these things. So let's talk specifically about CloudWatch. CloudWatch is AWS service, and it gives you generated metrics and logs and events over time to understand the behavior of your system. So CloudWatch, just regular CloudWatch, is metrics, right? So you get a bunch of built-in metrics with CloudWatch. So for example, when you're using EC2, you get metrics for EC2 for things like CPU utilization. You get metrics on how much network throughput the instance is getting, all that kind of stuff. You can also then put in custom metrics. So you can have a custom metric on things that we can't read off the hypervisor and generate for you automatically. So for example, memory utilization or number of threads on your Java process or something like that. So you can make a custom metric out of really anything. And then CloudWatch Logs is a service where there's a logging agent. The logging agent gets installed on your instance, and you can point it to any logs on that instance, and it'll send it up to the CloudWatch log service, and it's a centralized logging service. And so you can also do notifications and alarms in CloudWatch and CloudWatch Logs. So you can set up an alarm for something like when my CPU utilization on this instance or this group of instances is over, say, 80% for 5 minutes, trigger an alarm. You can also take an action on that alarm, and I'll talk about that as well. And in CloudWatch Logs, you can do alarms as well. So you can inspect your logs and search for, let's say, 404 in your web access logs. And if you get more than a certain amount of 404s, you can trigger an alarm on that. So you can get pretty customized with alarms. You can also inspect, navigate, zoom in, correlate issues across time to investigate what's going on. And this is a fairly new feature. So if you generate metrics from your CloudWatch logs, you can jump directly to those logs from the metric. And you can also generate additional metrics from your log data. So for example, if you're creating a metric on how many 404s you have, that's something you can do before. So then you can take action and correct issues automatically off of what's going on in your logs. So we have a service called Lambda. It is our serverless compute service. And you can trigger a Lambda function off of alarm. So let's say you need to fail over. So you see, oh, my app is down. So I need to fail over my DNS to point to my copy of my app in another region. You can trigger that off of an alarm. You can also trigger other things off of alarms. So for example, if you just need to scale up, right? So you can do an auto-scaling trigger off an alarm. So you can say, oh, my CPU utilization is really high. I'm now going to launch more instances and add them to the load balancer and scale up. You can do that off of your alarms. So let's talk about some recent improvements within the last year that we've changed with the CloudWatch service. So first of all, we dropped the price on custom metrics, so it's now less expensive to do custom metrics. We keep adding metrics from more services. So example, CloudTrail, Elastic Beanstalk, SCS now can all send to CloudWatch or CloudWatch logs. We've made it simple to navigate from your metrics back to the originating logs that generated those metrics, so you can see which specific events triggered a metric. And it used to be that CloudWatch only retained data for 2 weeks. It is now up to 15 months, so it retains data for a lot longer. We also added support for arbitrary metric percentiles. We released a CollectD plugin to simplify metric collection. So CollectD is an open source tool, so you can use that to generate custom metrics really easily. We've improved the web console and the dashboards in a bunch of ways over the past year. And so outside of our services, again, it's not just about CloudWatch, it's about our partner ecosystem for logs as well. So again, monitoring is hard, and every team is going to have unique needs. So I have customers who use just like our services for monitoring and logging. I have customers who use partner services, so they use things like Sumo Logic or Splunk. Those are all really common too. I see a lot of Elasticsearch, so Elk Stacks as well. So we have a rich partner ecosystem. We have a lot of solutions that are integrated directly with AWS and with AWS logs. So there's products that consume ELB logs or CloudFront logs, CloudTrail logs help you analyze those as well. And most of our customers use some mix of our services and partner services as well. And so AWS is all API driven, so we give you the flexibility to mix and match and script against all of our services as you need to accomplish your job. So in terms of CloudWatch logs, again, CloudWatch logs is a centralized logging service. It allows you to search your logs, monitor those logs, stream the logs out to various places, retain logs, and then CloudWatch logs actually doesn't have a limit of 15 months. With CloudWatch logs, you can store your logs as long as you want. And it is all encrypted at rest and in transit with how the agent communicates to the service. And so in terms of getting things into CloudWatch logs, EC2 has, you just install the agent to get anything on an EC2 instance up to CloudWatch logs. CloudTrail has native integration. You can push your CloudTrail logs up to CloudWatch logs. Lambda also has native integration with CloudWatch logs. So if you want to see the output of your Lambda functions, it automatically gets streamed to CloudWatch logs. And ECS has a logging agent as well. So if you're using our container service, you can just install the logging agent, and it will send up to CloudWatch logs. Now, how do we get data out of CloudWatch logs? So you can export data into S3. And then from S3, you can import it into something else like Splunk or some partner solution. Once it's in S3, you can do a lot of things with it. You can also have your CloudWatch logs trigger Lambda functions. You can also have your CloudWatch logs streamed directly to our managed Elasticsearch service. Or you can also do the same thing, but with an Elk stack where you manage it as well. And lastly, you can send CloudWatch logs to Kinesis, which is our live streaming service. So let's just quickly summarize what Lambda is before diving a little bit deeper here. So again, Lambda is our serverless compute service. The way it works is that it currently supports Java, Node.js, Python, and C#. And so you basically write a function in any of those languages, you send it to the Lambda service, and then you execute it either on a schedule, arbitrarily, or based off of an event. So an event would be something being dropped in S3, or you can trigger it off of an SNS function, or an SNS notification. So there's a lot of events that can trigger a Lambda function to be executed. So we see customers building serverless apps. So you have an app that has like Lambda and DynamoDB for its persistent tier and S3 as well. And so then you don't even need to spin up any instances. But in this case, we're just going to talk about how to use Lambda to take actions based on your alarms. So first of all, let's go through our first use case here. So let's talk about how do you centralize logs from an ELB. using S3 bucket triggers. So if you need web access logs, right? Typically you have those access logs. They're on each instance. So if you have an auto-scaling group, you can have 3 instances, you can have 9 instances, you can have 100 instances, depending on the traffic. And so it's not really convenient to have your web access logs spread out across all those instances, because you have to either be, you can run the CloudWatch logs agent, but it's an extra agent that you have to run. So what you can do instead is, if you have an ELB in front of all your web servers, or an ALB, you basically can enable, it has a logging feature. It generates web access logs. Those access logs are dumped into an S3 bucket if you're choosing. So how do we get something from an S3 bucket into CloudWatch logs so that we can search it and filter it and have a central place where it's all stored? So what we do here is, again, we have the ELB delivers logs to an S3 bucket. S3 has this feature called event notification. So you can be notified of an event anytime an object is created, deleted, updated, any of that. So in this case, we're going to have an event notification that triggers from an object's creation. So when the log file gets dropped into the S3 bucket, it's going to notify Lambda. So Lambda knows, hey, something just got dropped into this S3 bucket. Lambda is going to trigger a function. The function is going to read from the ELB log and publish the contents of that log from S3 into CloudWatch logs. So the way this works is we would provision 3 instances, running Apache or IIS or Nginx or whatever web server you prefer. We would configure a load balancer. It could be an ELB, it could be an ALB, it doesn't matter. In this case, it's an ALB, so application load balancer. We would create a target group that contains those 3 Apache web servers. We would then enable ELB log delivery to S3. So again, it's just a check mark. You can also do all this in the CLI. So in here, we created an S3 bucket called Apache ELB logs, and we've enabled the collection of those logs in there. And then we're going to configure that S3 bucket where the logs are being dropped to trigger a Lambda function. So whenever something hits the Apache ELB logs bucket for the event type, an object being created, it's going to trigger my S3 or my Lambda function. And the Lambda function, what it basically does is it uses the S3 getObject API to download the log file and read it. And it then uses the CloudWatch logs, put logs event API to post that log into CloudWatch logs. And don't worry about this code. It's on our GitHub page. There's going to be a link at the end of the presentation where you can download all of it. And so then we go to this our web page here. So that generates some logs because we've gone to the web page and generated some access logs. And we verify that those logs are now indeed in S3. They get delivered in a minute or so, basically, to S3. And then we go into our CloudWatch logs console. And now not only are they in S3, they're actually in CloudWatch logs as well. So that's great. So now we have centralized logging all set up. What are some useful things that we can do with it? Well, we can filter. So here I'm filtering by gets. So I don't care about puts. I just want HTTP gets for the last day. So I can do that pretty easily. My query is just get HTTP. I can create a pattern that requests things like, what is a request with more than 1 millisecond of latency? So I create a filter pattern, and it shows me only those entries and logs where it's higher latency than 1 millisecond. And so now I want to create a metric. So I want to know if there's a lot of requests that create more than that have more than 1 millisecond of latency. And so I can create a metric. I write a filter pattern for it. And so now it's going to trigger that metric. So I can click on the metric and see how many times has this happened. And then I can view a graph for ELB latency. And so then what I can do from here is create an alarm off of this. And I can do various actions off the alarm. And I'll show you how to do that next. And so just some key takeaways here. Anything in S3 can be streamed into CloudWatch logs. So it doesn't have to be an ELB log. It could be a CloudFront log. It could be anything in general that gets sent to an S3 bucket. And it's pretty easy to send things to S3 in general. And then you can search and extract metrics from those logs in near real time. So it doesn't take a long time for something to show up in CloudWatch logs. So now let's talk about customizing alarms. So you get an alarm, and you don't want to know that, hey, this alarm has triggered. You want to know what has actually triggered this alarm, what's the information that I need in the alarm text for it to be useful for you. So what we're going to do here is we have CloudWatch logs. We have an alarm configured in CloudWatch logs. That triggers an SNS topic. SNS is our simple notification service. And the SNS topic triggers a Lambda function. And Lambda, what it does is it looks at that specific alarm. It gets the filtered logs from CloudWatch logs, and it emails you the logs, the actual logs that triggered the alarm in your email. Now, it doesn't have to be email. I could also have Lambda, post to my Slack or my HipChat, or really do anything. It's API driven. Anything that's an API you can trigger with it, so you can deliver those logs on some other method as well. And so what we're going to do here is we are going to provision an EC2 instance with Tomcat running on it. We're going to install the CloudWatch logs agent on that instance, and we're going to verify that the agent is actually sending the Tomcat logs to CloudWatch logs. And then we're going to configure a pattern. So in this pattern, we're looking for unauthorized access requests, so 401, status code 401s. So we're going to create a filter pattern to only extract 401s. We're going to create a metric for that filter pattern. And we're going to create an alarm for that metric. So if I get more than 5 unauthorized accesses or 401s in 5 minutes, it's going to trigger an alarm. The alarm trigger, the way it works is it's going to send a notification to an SNS topic. Now again, I'll show you what that topic text looks like. It's not super useful. It shows you, hey, this alarm has been triggered. It doesn't show you what's actually going on. So what we're going to do next is we're going to create a Lambda function. That Lambda function is going to be triggered by that SNS topic. So the SNS topic that is triggered by my CloudWatch logs alarm is going to trigger this Lambda function. And the Lambda function, it's going to get the metric information by using the CloudWatch logs describe metric filters API. It is going to get the relevant log data, so it's going to pull the actual log data using, again, another API in CloudWatch logs. And it is going to use SES. It's going to use SES's API to email me that relevant log data. So to actually trigger this, we would go to our server, trigger a 401. So this is what the alarm looks like that you get from SNS. So as you can see, it says, oh, well, your threshold for an alarm has been crossed. So we're going to email you this alarm so you know what the monitored metric is and that it's been triggered. Not much else. That's not super useful. But then when you get the email from the Lambda function, that's far more useful. So here we've configured it so that it shows me the alarm name. It can link to a runbook I have. So if I know this error shows up kind of frequently, you can have a runbook ready to go for your operators to click on to see what to do in this case. You can include things, I blanked it out here, but you can put your specific account ID. So a lot of our customers have multiple AWS accounts, which region it's in. And then you can actually dive deep into the actual log. So we see what instance has triggered the log. We see what IP address has triggered this event. And then you can do something like, as another action after this, you can probably script it to use our web application firewall service and block this IP address automatically, right? So it gets blocked from even reaching the web servers. So there's all kinds of things you can do here. And so just some key takeaways here are that alarms can be customized to add specific details about your actual issue. So when you see a spike in a metric, you can see what's actually triggering that spike. And the Lambda function can be extended to add in other information that you would find useful, such as runbooks or really anything else in that notification. And actually, in practice, I see this being done way more as like chat ops, so in things like Slack notifications than emails, because emails can be overwhelming, and putting it in your Slack is probably a little bit more useful. So lastly, let's talk about log analysis. So the problem here is that we want to analyze some of our logs, but we don't want to leave the cluster running all the time. So you can configure your CloudWatch logs to stream out to an Amazon Elasticsearch cluster It's just built in. You can right-click on any log stream and say, I want to stream out to Elasticsearch. But that assumes that your Elasticsearch cluster is running all the time. You might not need it to run all the time. So you want to save money, so you want to have a temporary cluster. So you also don't want to spin up your own Elasticsearch cluster. It's a lot of undifferentiated heavy lifting. You don't want to manage that cluster, maintain its uptime. And so you want to build an on-demand Amazon Elasticsearch cluster. And you want to analyze not just like the live stream of all your data, you want to analyze data from a specific time period. So you had some incident happen, you only need to have certain logs. So the way that we would do this is we would export logs from a specific time frame from CloudWatch logs to S3. We would again use the same object create event notification to Lambda. Lambda would then has to take those logs and transform them into JSON so that they're useful for Elasticsearch. So we're going to have Lambda do that and send them to an Elasticsearch service. So in this case, what we're going to do here is VPC flow logs. So VPC flow logs, they are logs, basically network logs of what's going on in your VPC. So they have things in them like the source IP address, destination IP address, port, protocol, basically everything except the contents of the packet in terms of network data that's going on in your VPC. So we're going to configure VPC flow logs. In this case, you can configure them for your whole VPC. We're just going to configure them for a specific Elastic network interface. So we see some weird traffic on an instance, and we want to investigate that instance's network traffic. So we're going to turn them on, and as soon as you turn them on, VPC flow logs automatically work with CloudWatch logs. So this is the data that you would get. So again, this is source IP address, destination IP address, whether the request was accepted or not, so on. And so then we're going to create an Elasticsearch cluster. And again, this can all be scripted as well. So we're going to create an Elasticsearch cluster with just one node. It's going to be temporary. And so then what we're going to do is we're going to read the flow logs from S3 by, again, using this get object API. So our Lambda function is going to read the actual flow logs. It's going to transform the flow logs into JSON. And it's going to insert the logs into Elasticsearch by going to its HTTP endpoint. And so once that's all set up, all we have to do is, again, this is just built in. You can right-click on any CloudWatch log stream and export it within a certain time range out to an S3 bucket. And that S3 bucket can be in your account. It could be in another AWS account. And so then it's exported to S3. So we can see it here. This is the way it looks like. There's a different folder for each ANI. And so as soon as that happens, it gets injected into Elasticsearch. And that's what it looks like. So this is the raw data in Elasticsearch. And Elasticsearch gives you a lot of nice stuff like different dashboards. There's some, on our GitHub page, there's some built-in dashboards you can download for Kibana to load into your Elasticsearch to make sense of things like flow logs. And again, here's another summary of the dashboard. So you can get things like top 10 destination or source IP addresses, all kinds of useful stuff here that would be hard to just get from the raw log files. And so the key takeaway here is that we can send historical data within any given time frame on demand to the Elasticsearch service. This reduces cost because I don't have my Elasticsearch cluster running all the time. Because it's a managed service, I don't have to worry about like manually setting up Elasticsearch. I can just spin it up, kill it when I need to, and it makes troubleshooting a lot easier for you. So just to recap before I take some questions here, so monitoring is still really hard. The tools I've talked about here hopefully can make it easier for you. And CloudWatch logs and Lambda are both powerful tools. They're very open-ended tools, especially Lambda, that will allow you to do a lot of flexible things to make sense of your logs. So just some useful links. We got full documentation for CloudWatch and Lambda up on our website. These Lambda functions that I've used here, they're on our GitHub page. So if you just, if you don't want the full URL, just go to it's github.com/AWS Labs. We've got a bunch of repos in there. If you just search for CloudWatch logs in the repos, there's all kinds of useful stuff there. We also have a blog where we post both, example use cases and also, customer use cases on what customers are doing with CloudWatch and Lambda. And so that's all I have for you. So just remember to complete your evaluations. And I'm just going to take questions off to the side. So if anybody has a question, just come up here. All right, but thank you for coming, and enjoy the rest of the summit.